Hello students, I hope that you are good, well and fine. In today's session, we will be seeing integration by parts. Okay, so integration by parts means what? If you are having u and v, any two differentiable functions of a single variable x, okay, then by the product rule, the differentiation will be what? As you can see, d over dx of u times v is equals to u times derivative of v with respect to x plus v multiply with derivative of u with respect to x. You will get this by product rule. Okay, then what you have to do, what we are doing is applying integration to both sides. Then what you can get is uv is equals to integration of u times dv by dx plus integration v times du by dx. So this can be rewritten as what? That integration of u times dv by dx is equals to u times v minus integration of v times du by dx with respect to x. Okay, now if you put u is equals to fx, okay, and if you put dv is equals to dx is equals to some function gx, simple. What we are doing is, as we already took u and v some function of x in terms of x, okay, then u can be rewritten as in the form of fx, and say v is equals to some hx, where dv, if you differentiate it, the hx, the differentiation of hx will give you another function in terms of x, so you will get gx. Okay, so dv by dx is equals to some gx. Now du by dx is equals to what? F prime x, and v is equals to what? Integration of gx. This means your expression will be now rewritten as integration of fx gx dx is equals to fx integration of gx dx minus integration of gx dx, and this integration now can be multiplied with derivative of fx. Okay, simple. I hope that it is clear that what is happening. Now this means integration of fx gx is equals to fx times integration of gx dx minus integration of whole f prime x multiply with integration of this gx dx. Okay, now if we take f as the first function and g as the second function, then this formula may be stated as following. So first function multiply integration of second function minus integral of differentiation of the first function multiply integration of the second function. Simple. So let us see an example. So integral of x cos x we have to find. So put fx is equals to x, or first function as x and second function as cos x. Then integration of x cos x will be what? First function multiply with integration of second function, which is integration of cos x dx. Okay, now minus, now integration of the first function derivative. First function is x, so first function derivative multiply with integration of second function. Okay, simple. Now solve them. So x sin x, you will get x sin x. Now what about this? This will be just 1, and this will be what? This will be what? As you can see, this will be sin x. Integration of cos x dx will be just sin x. Okay, so 1 multiply sin x give you sin x. Now integration of sin x will be minus cos x, so you will get your final answer as x sin x plus cos x plus c. Okay, and now suppose we take fx is equals to cos x and gx is equals to x, then what will happen? Now as you can see, First function is your what? Cos x. Now cos x integration of x dx minus differentiation of first function which is cos x, integration of second function which is x dx. So now evaluate them. You will get what? Cos x multiply with x square by 2. Yes. Plus, because the differentiation of cos x is minus sin x. Okay. And x, this will be x square by 2. Okay. Now cos x multiply with x square plus x square by 2 plus integration of sin x multiply with x square by 2. Now, as you can see, it shows that the integral x cos x dx is reduced to the comparatively more complicated integral having more power of x. As you can see, this is now complicated. Okay, this is now complicated. Okay, therefore the proper choice of the first and the second function is very important here in integration by parts. Okay, if you do integration by parts, then the choice of first and the second function are very crucial. Okay, so whenever you see a question in which two terms are getting product, two terms are getting multiplied, and those terms are either from trigonometric or polynomial or log or exponential form. Okay, clear? Then you can choose your first function according to the order of ILATE. I means inverse trigonometric function, L means logarithmic function, okay, T means trigonometric functions, and E means exponential function. Simple. Okay, let us move next. Now let us see some remarks. It is worth mentioning that integration by part is not applicable to product of functions in all cases. For instance, the method does not work for integration root x sin x dx. The reason is that there does not exist any function whose derivative is root x sin x. Okay. Now observe that while finding the integral of the second function, we did not add any constant of integration. If we write the integration of the second function cos x as sin x plus k, where k is any constant, then what will happen? Let's see. So first derivative, integration of second derivative which is sin x plus some constant k, minus integration of derivative of first function which is just 1, and integration of second which is sin x plus k. Now integrate them. What you can get? X times sin x plus k. This will be what? Minus cos x minus kx plus c. Okay. Now what? Now as you can see what is happening. Now take what? Multiply. What you can get is x sin x. Yes, x sin x. Now cos x, and minus kx and plus kx will be cancelled, as you can see. So you only left with plus c. So this shows that adding a constant to the integral of the second function is okay. So far as the final result is concerned while applying the method of the integration by parts. Okay. Now third point, usually if any function is a power of x or a polynomial in x, then we take it as the first function. Okay. However, in cases where other function is inverse trigonometric function or logarithmic trigonometric function, then we take them as our first function. So as I have already just told you that apply the ILATE rule, which is I inverse trigonometric function, L means logarithmic function, A means algebraic function or algebraic expression, T means trigonometric function, E means exponential function. Okay. So here find integration of log x dx. So how you are going to find integration of this? So very simple. To start with, we are unable to guess a function whose derivative is log x. Okay. We take x as our first function. Then what will happen? Then constant function 1 as the second function. Okay. As you can see, log x can be rewritten as 1 multiply log x. Yes. So first function will be log x and second function will be this. constant function which is 1. Now integral by using by parts, what you can get is first function as it is, integration of second function as you can see x, now minus differentiation of first which is just x, integration of second which is x, x and x can be cancelled directly, you can get integration of just dx integration, so you will get x log x minus x plus some constant. So integral of log x dx will be what? X log x minus x plus some constant. Okay, I hope it is clear to you. Let us move to some more examples to know this concept better. Okay, so find integration of x ex. As you can see, we are having product of two different functions. One is a kind of algebraic function or polynomial function type, and another is exponential function. Okay, so according to the ILATE rule, what we will be choosing for as our first function as okay, so x will be our first function. Okay, x will be our first function because I means inverse trigonometric function, L means logarithmic function, A means algebraic expression or algebraic functions like x, and E comes at the end of ILATE. Okay, now what? Now first function as it is, this means x, integration of second, integration of ex is just ex minus bigger integration, inside it what you can get is differentiation of first function which is 1. Now integration of second function which is just ex, now 1 multiply ex, so integration of ex will be ex, so you will get what? X ex minus ex plus some constant. Okay, I hope it is clear to you. Okay, let us move to next example. Example number 20. So find this integration. As you can see, what is happening? Okay, what is happening? So according to the ILATE, if you choose, your algebraic expression type will be your first function. Okay, clear? Okay, no, sorry. According to the ILATE rule, the inverse trigonometric function will be your first function choice. Okay, so inverse trigonometric function which is sine inverse x will be your first function. Okay, so first function will be sine inverse x and second function will be the remaining terms which is x divided by root of 1 minus x square. Now what you can do is, okay, now integration of this we have to find. Yes, integration of, you will see why we are finding this integration at first. So integration of x dx divided by 1 minus x square will be what? Put t is equals to 1 minus x square. Yes, if t is equals to 1 minus x square, then derivative of this with respect to x will be what? Minus 2x. This will gives you dt is equals to minus 2x dx. Okay, now integration of x dx root of 1 minus x square. Now this means it is equals to minus of half integration dt by root t is equals to minus of root t. Okay, which is equals to minus root 1 minus x square. Okay, now what? Now integration x dx divided by root of 1 minus x square can be rewritten as whose integration will be, as we just saw, is equals to minus of root 1 minus x square. Simple. Okay, now the main question, which is integrate x sine inverse x divided by root of 1 minus x square dx. As we took first function as sine inverse x, so sine inverse x remains as it is. Integration of the remaining thing is minus of root 1 minus x square. Now minus derivative of first thing, derivative of the first function will be 1 by root 1 minus x square, and integration of the second function will be minus root 1 minus x square. As you can see, this term will be cancelled. Now you left with minus so sine inverse x multiply with minus root 1 minus x square, this will becomes plus integration dx. So this will be just x, the integration of this will be just x. You will have minus root of 1 minus x square sine inverse x plus x plus some constant. So this will be your final answer. Okay, I hope it is clear to you. Okay, so let us move to the next problem. Problem number or example 21. So find integration of ex sin x dx. Now, as you can see, according to the ILATE, exponential function will be the last to choose, or second function. Okay, so here you can see the first choice will be sin x. Okay, clear? Okay, now as you can see what is happening. So first function as it is, as ex will be remains as it is. Now derivative of integration of sin x will be minus cos x, now plus integration of derivative of first function and integration of second function will gives you this now, which is equals to minus ex cos x plus I1. Say this integral as I1. Okay, now I1 is just nothing but ex sin x. Yes, ex sin x, as you can see, minus integration of ex sin x dx. Yes, okay, we just rearrange thing. So I1 is equals to this integration of ex sin x dx. Okay, plus, clear? I hope it is clear to you. Okay, now what we are taking? Now taking ex and cos x as the first and second integrations respectively in I1. So I1 is this, just nothing but this. Then I1 is equals to ex sin x minus ex sin x dx. Now substituting the value of I1 in 1, we get I is equals to minus ex cos x plus ex sin x minus I, or 2 times I, which is equals to this. This means I will be ex by 2 sin x minus cos x plus c. Okay, and alternatively our integral can also be determined by taking sin x as the first function and ex as the second function. You can choose that also. Okay, clear? Okay, so in here we tried the different approach, but but in here we tried the ILATE approach. Okay, now integration of the type integral ex multiply with fx plus f prime x dx. Okay, then what will you get? So I is equals to integral of ex multiply with fx plus f prime x dx. Now multiply it, what you can get? Integration of ex fx dx plus integration of ex f prime x dx. Now this integration I will be taking as I1, as you can see, and this will be just rewritten as this in this form. Now taking fx our first function and ex our second function, the I1 will be what? I1 will be first function as it is. Okay, first function which is fx as it is, integration of ex is just ex minus differentiation of first function which is f prime x and integration of second which is ex. As you can see, what will happen? Now put your I1 value here. This gives you what? This expression, and this expression gives you what? Just nothing. You can cancel these terms. Okay, you will only left with ex fx plus c. So your integration of ex multiply with fx plus f prime x dx is equals to ex fx plus some constant. Okay, clear? Okay, now as you can see, example 22 says have two parts, we have to evaluate integration. So first says ex multiply with tan inverse x plus 1 by 1 plus x square. As you can see, this is what form? This is of the form this, that this fx is your what? Tan inverse function, and derivative of tan inverse function is what? 1 by 1 plus x square. So this means ex fx plus f prime x is written, and we know what will be its integral. Its integral is ex fx plus some constant. So ex is ex, fx is tan inverse x. So as you can see, your final answer will be ex tan inverse x plus some constant. Okay. Now second part, I is equals to x square plus 1 multiply with ex divided by x plus 1 whole square. So what is happening? As you can see, the first thing what we are doing, in numerator we are adding and subtracting 1, as you can see here. So what can you get is x square minus 1 plus 1 plus 1. Okay, so break them. What you can get is that, okay, clear? So x square minus 1, ex multiply with x square minus 1 divided by x plus 1 whole square. Okay, so this can be rewritten as you can see, ex multiply with x minus 1 divided by x plus 1 plus 2 divided by x plus 1 whole square. Okay, now take fx is equals to x minus 1 divided by x plus 1. Okay, this means f prime x will be what? Denominator. So we will be applying to find f prime x quotient rule. So denominator square multiply with the denominator, now going to multiply with the numerator derivative. So numerator derivative is just 1. So x plus 1. Okay, now minus numerator getting multiply with the denominator derivative. So still 1. So you will get 1 minus x. So you will get x plus 1 plus 1 minus x. So x and x term will be cancelled. You only left with 2 divided by x plus 1 whole square. Okay. Thus, this gives you what? The integrand is of the form ex multiply with fx plus f prime x. Okay. So you fx is what? Your x minus 1 divided by x plus 1. So this means what is happening? Integral of x square plus 1 divided by x plus 1 whole square ex dx will be what? Ex multiply with fx. Fx is just nothing, x minus 1 x plus 1. So ex multiply x minus 1 divided by x plus 1 plus some constant will be your final answer. Okay, so that's it for now. Okay, we will be back with NCERT exercise 7.6 problems. Okay, which is based on what? Integration by part concept. And this concept, the integrals of the form ex multiply with fx plus f prime x. Okay, so if you didn't get, okay, this concept, don't worry. If you practice it more, you will get to know that how we are forming our this form ex multiply with fx plus f prime x, and also you can able to find integration using the by parts form. Okay, if you practice more, you will get used to it. Okay, so that is it for now. So thank you.